Hello, continuing from our previous video, in this tutorial we'll learn the basic usage of the SDAPI plugin by trying out an example widget within Unreal Engine Editor. Specifically, we'll explore how to use Stable Diffusion through Editor Utility widget that we prepared for this tutorial. This will help those who haven't had a chance to experiment with the Stable Diffusion before. First, let's open the editor. As mentioned in the previous video, you can find the editor utility widget in the engines folder. Alternatively, you can open it by going to Tools, Editor Utility widget, or Stable Diffusion widget like shown here. This is the widget window. In this tutorial, we'll primarily focus on how to use various features within this editor. When you open the editor, you'll see a window in the center labeled API not connected. This means that the plugin is not currently connected to the API server. This plugin connects to the Stable Diffusion server through the address set in the Connect Target section below. Currently it is set to local, but you can check or edit this in the project settings under SDAPI section. In the settings under API URL map, you can see that the address to port pair for connecting to the local server has been configured. As you can see, local key has a value of localhost address set. And because I have no API server running in this address to local server, you'll see API not connected here. Because widget has failed to communicate to a live API server, the Launch Local AI button is active. Pressing this button will start the Stable Diffusion server in your local environment if you have set the execution link in the SDAPI setting. Please refer to previous tutorial for details on how to set up the server. Once the server is online, you may have to either restart the widget or change the connect target from local to some other keys on the connect target list. Doing this will let you attempt at connecting on the live server again. Once the widget has made a connection to the live server, API connected and initialized will appear on the widget. Now you're ready to use the editor. Upon connecting, you'll notice that the model section at the top is either no longer empty or Dropbox menu is not empty. If you used the Stable Diffusion before, you might be familiar with the concept of models. These models are essentially training data that allows Stable Diffusion AI to generate images. You can download additional models online, and quality of the generated images often depend on the models. For this tutorial, we'll use the pre-prepared model. If you want to find new models, you can obtain checkpoints from Civet AI website or Hugging Face website. Place these checkpoints in the model/Stable Diffusion folder within the directory where Stable Diffusion AI is installed. After restarting the API server, you should be able to see the models in the list under model text. Now let's start examining the basics of creating images in the editor widget. The mode determines how you generate images. Currently, the plugin supports three modes: text to image, image to image, render target to image. Let's begin with text to image. It's the simplest way to generate images. You describe the image you want in the prompt, and it generates an image based on the description. For example, let's input landscape, best quality, and mountain into the prompt and generate an image. You can specify the size of the images in the size X and size Y. Step determines the length of the drawing process. Be aware the larger sizes and steps result in longer image generation times. If you want to create a similar image as before, you can set the same prompt model and fix the seed. The CFG parameter controls how faithfully the prompt is reproduced. Setting it too high may distort the image, so typically it is set around 9 to 10. Note that the choice of sampler also slightly affects the generated images. You may want to experiment or investigate this further. This topic is more closely related to Stable Diffusion than plugin, so we'll keep it brief. Now let us generate the images with the current setting. I'll press the generate button. As you can see, the image has been generated and is being shown here. Clicking the Save button will save the images in the location you've configured in the project folder. In this case, the image is saved under Procedure/Texture folder. Here you can see the image you see on the editor exists in the content browser. Now we'll examine image-to-image mode. Image-to-image mode requires an image as a reference. Image-to-image mode will generate a new image based on the prompt and the reference image. For this demonstration, I will use the image that I prepared, image_sample. With the reference image, I'll put happy face and best quality as prompt. There are some prompts like best quality that enhances the quality of the output image, so be sure to research them out yourself. I'll press the generate button now. Image to image may produce image deviated from what you expected. This is due to denoising strength parameter. Higher strength values significantly transform the original image, while lower values produce slight changes. Let's lower the strength and try again with 0.465 denoising strength. The image still holds some resemblance of the original image like you can see here. Now let's explore render target to image. Render target is an asset that lets you turn what a camera sees into a texture. Refer to Unreal Engine documentation for details on how to make the render target asset. I'll use a render target asset that captures the left pad of the sample map included in the plugin. This is the render target asset I'll be using. It is shown on the left pad on the sample map here. As you can see, what the camera is currently seeing is what's shown on the wall behind the camera. Therefore, this essentially allows you to turn a view from the camera into an image, then run an image-to-image processing on the runtime. Now let us go back to the widget. I had previously set the sample render target a couple minutes back. Then let us change the prompt into best quality, cyberpunk, sky, and city. I'll be generating the image now. As you can see, the image generator here is a modified version of the render target. This feature is very useful when you're to turn something that a camera sees into AI-enhanced image in a runtime. Additionally, you can use the ControlNet feature to partially control the image's appearance, which can be helpful in creating perfect images. Let's try the ControlNet feature. We'll first look at the example using text-to-image since it is most straightforward. ControlNet is an extension program installed through Stable Diffusion. Requires a separate ControlNet specific model to be installed. If ControlNet isn't installed, the relevant menu options in the editor will be disabled. I'll provide links to the Git page where you can install ControlNet and links for obtaining ControlNet models in the video description. After installing ControlNet and its models, restart the API server, you'll be able to use this feature. In this tutorial, we'll use the ControlNet preprocessor and a model that's already installed. Let's use the ControlNet preprocessor called Kenny to preprocess the image. Choose the model as well. Kenny is the ControlNet that outlines the shape in the data texture, effectively fixing the shape. The preprocessor takes the image set in the ControlNet data texture, uses it to create a data image. This data image is then used to fix the shape in the ControlNet model. I'll put the sample image we previously saw in here. Then I will press the generate button. Voila! A high-resolution image based on sample image has been created. Now, to make it prettier, let's change the settings a bit, then generate based on the changed setting. You can see that the image has transformed accordingly. Control nets are particularly effective when generating images using text-to-image as they provide a framework for creating images. While they can also be used with image-to-image, keep in mind that they place more importance on control net images, which can result in mixed images. Please consider this when using them. This editor's implementation is written in both Blueprint and C++, making it a valuable resource for your game development projects. As you can see on the widget, the part of the widget is there for you to tinker around or use them as an example. You may find the source code for these nodes for your use. More detailed information is available in the documentation, allowing you to create various games and features using Stable Diffusion plugin. We'll see you in the next video.